You may already know what it means for a line to be parallel or perpendicular to another line, but if I'm giving you a line, would you know how to find the equation of a line that is parallel or perpendicular to that given line? And on top of that, what if you need that parallel or perpendicular line to pass through a specific point? That just adds another wrinkle of complexity into it. Well, in today's video, I'm going to show you exactly how to solve a problem like this if you're given a line and a point that you know your other lines have to pass through. We're going to come up with equations of lines that are perpendicular to the given line and parallel to the given line and pass through the given point. And by the end of this video, you should be able to do these kinds of problems much more easily on your own. So if that sounds good to you, be sure to stick around to the end of the video, and let's go ahead and jump right into the problem. Write the slope-intercept forms of the equations of the lines through the given point, parallel to the given line, and perpendicular to the given line. So this is a two-part question. It's kind of weird wording here, but basically what we need to do is find the equation of the line. It has to be given in the slope-intercept form, the equation of the line that is parallel to the given line, and the equation of the line that is perpendicular to the given line, and it has to go through this point. Okay, so we're given two pieces of information. We are given a line and we're given a point. We need to come up with two different line equations, two different parts to this problem. We'll talk about them separately. So let's start with part A. Okay, part A says we need to find a line that is parallel to the given line and it has to go through this point. So if we're trying to write a line that is parallel to a line and goes through a specific point, there's a couple things we need to figure out. As with any equation of a line, there's really two parts to that: the slope and the y-intercept, or some other sort of information that tells you a point that your line goes through. You can kind of figure out the y-intercept once you know the slope and another point, because there's other forms that a line can be in, like for example, the point slope form. Obviously, we need to get our line into the slope-intercept form, but we can actually start with a different form, and then we can kind of simplify or manipulate our line equation to get it into the slope-intercept form. So don't worry about the fact that we need the slope-intercept form yet. For now, let's just think about how to write a line equation that is parallel to this line and goes through this point. Okay, the way that you want to do that is to first figure out the slope of the line that we are dealing with. If we know that our line has to be parallel to this line, we first need to know the slope of this line so that we can then use that to find the slope of the line that we're trying to come up with. So to do that, what you want to do is get it into the slope-intercept form or the slope point slope form. And then you can use that to figure out what the slope is. So in this case, we have this in a form that's not particularly useful. What we can do though is manipulate this equation to get it into a form that is useful. That form would be the slope-intercept form. So to do that, you just want to get y equals mx plus b. So we just need y equals some number times x plus b. And this will tell you our slope. Whatever number is being multiplied by x, once it's in this form, will be the slope of this line. So in this case, to do that, all we have to do is subtract x from both sides, and we will move it over to the right side of our equation. And we would get y equals negative x plus 7. Okay, so now we've got this in the slope-intercept form. We know that the slope of this line is negative 1, because negative x is the same as negative 1x. So basically our slope is negative 1. And the y-intercept of the given line is 7. Okay, that does not mean that the y-intercept of the line we want is 7. It means the y-intercept of this line is 7. Okay. But we do know that the slope of this line is negative 1. This is important because the line that we're trying to come up with has to be parallel to this line. Well, what does it mean for two lines to be parallel? In order for two lines to be parallel and never intersect each other, they have to have the same slope. So we know already that the slope of our line has to be negative 1. So that's super helpful. Now we know we have to come up with a line equation which is parallel or has a slope of negative 1 and goes through the point negative 3, 2. Okay, so to do that, if we know a point and we know our slope, the easiest thing to do would be to use the point slope form of a line. The point slope form of a line is y equals m times x minus x0 plus y0, where you have a slope of m and goes through the point x0, y0. So basically we need an xy coordinate of a point that our line has to go through. In this case we have it, it's -3, 2, and we need a slope of our line, which in this case we already have, is -1. So as long as our slope is -1, our m is -1, and then our point is -3, 2, which means that our x0 is -3 and our y0 is 2, we should be good. So we pretty much just have to plug those in. So doing that is going to give us y equals -1 times x minus x0 is -3. So keep in mind we have x minus -3. Be very careful about that. When your x coordinate is a negative, it's actually going to end up kind of doing the opposite here. And then plus y0, which is our y coordinate, which is 2. Okay. So now that we've written this in the slope point form, or the point slope form, depending on how you want to say it, we can rearrange this to get it into the slope intercept form, which is the form that the question asked us to get it in. Okay. Before we continue on with that, though, I just want to make sure you're following along. If this makes sense so far, just drop a comment below that says got it so far. And if you are getting some value out of this video, do me a favor and hit that like button while you're down there too. So now to rearrange this to the slope intercept form, all that really means, that's kind of the most straightforward form to get a line into, because all you really have to do it is simplify your equation. Basically expand out, distribute throughout the parentheses, combine all your like terms, just generally simplify your equation. Okay, so to do that, we want to first start by simplifying what's inside the parentheses here. So we have y equals -1 times x minus -3. These two negative signs are just going to cancel out, and we're just going to get x plus 3, and then plus 2 outside the parentheses. Okay, then this -1 is going to distribute into the parentheses. We're going to get y equals -x minus 3 plus 2, and then the -3 and the plus 2 can combine, giving us y equals -x, -3 plus 2 is -1. So now our slope intercept form is right here, y equals -x minus 1. So that tells us that our slope is -1 and our y-intercept is -1. And that is going to be a line that is parallel to this line and goes through this point. Okay. Now let's go on to part B. Part B says that we need a line that goes through this point and is perpendicular to this line. So we still have the same line and the same point, but now we know that it has to be perpendicular instead of parallel. So we're going to solve this very similarly to how we found the parallel line. However, our slope of the line that we're trying to create now is not going to be the same as the slope of this line, because if you make the slope the same, you're going to end up with a line that's parallel, not perpendicular. What do you need the slope of a perpendicular line to be? Well, it's not going to be the same, obviously. It's just going to be the negative reciprocal of it. What's a negative reciprocal? Well, to find it, you really just have to do two things. It's negative, so if your slope is negative, you have to make it positive. If it's positive, you have to make it negative. So we're going to multiply it by -1, basically. And a reciprocal is just flipping a fraction. So if you have a whole number, like we have here, it basically means put 1 over that thing. If you have a fractional slope, like if our slope was a over b, the negative reciprocal would be negative b over a. You would just flip the fraction and then make it negative. If we had negative a over b, the negative reciprocal would be positive b over a. If you have a whole number slope, like our slope is m, the negative reciprocal would be -1 over m. So you would just make it negative and make it 1 over that slope. So in this case, we have a slope of -1. The negative reciprocal of that is going to be positive, because this is negative, and then it's just going to be 1 over whatever that is. In this case, 1 over 1 is just 1. So the negative reciprocal of -1 is just +1. So we know that the slope of the line that we're trying to create in part B, the slope that is perpendicular to a slope of -1, is just +1. Okay, so now we know we need to make a line that has a slope of 1 And we still know that it has to go through the point -3, 2. So again, if you know the slope and you know the point, you can just use the point slope form of a line, which is just what we did in the last part. It's just going to be y equals mx minus x0 plus y0. So in this case, x0 is -3, y0 is 2, m, which is your slope, is 1. So you just pretty much have to plug those in for these three different pieces. Minus -3 plus y0, which is 2. And then in order to get it into the slope-intercept form, like the problem asked us to find it in, we just have to expand this out and simplify. So first, x minus -3 is the same as x plus 3. So that'll be what's in the parentheses there. And then distribute the 1. 1 times x is just x. 1 times 3 is just 3. And then plus 2 outside the parentheses. And then combine your like terms. So x plus 3 plus 2, 3 plus 2 is 5. So x plus 5. So now this is going to be the line equation that is perpendicular to the given line and goes through the point that we needed it to go through. And it is in the slope-intercept form like the problem asked us to get it in. Knowing how to create a line that is parallel or perpendicular to a given line and goes through a specific point is obviously a necessary skill for a pre-calculus class. But what if instead of being given a line that you can use to figure out the slope of your desired line, you're given 2 points that your line needs to go through? That's something that works out a little bit differently, and it's equally as important. So go click on that video over there, and I'll show you exactly how you can do that also.